Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discuss another important method, that is the iteration method. Okay, so this is actually in order, it is a second method. Okay, so you can see in this iteration method, so directly we are going to discuss a problem. Okay, so instead of discussing the general procedure, so we are going to discussing a problem. Okay, find a real root of the equation x minus sin x is equal to 1 by 2, correct to 4 significant figures. Okay, so correct to 4 significant figures. So we have to find out a real root. We have to find out a real root of the given equation x minus sin x is equal to 1 by 2. That real root correct to 4 significant digits. 4 significant digits means after the decimal point. So we have to write the 4 significant digits of the given approximate root. Okay, so see the solution. Given equation is x minus sin x is equal to 1 by 2. Okay, so now later I am taking it as f of x is equal to x minus sin x minus 1 by 2. Okay, so if you send this plus 1 by 2 LHS, it will become minus 1 by 2 equal to 0. That is, we are letting it here. So in a statement of the problem, he did not mention the any values a comma b. So now by using the trial and error method, okay, so we are finding those values. Okay, so first if you substitute f of 0, you will get a negative minus 1 by 2. Okay, so f of 1 minus sine of 1 by 2, again you will get minus 0.3415. It is also less than 0. So therefore f of 1 less than 0. And next letter is f of 2. So 2 minus of sine 2 minus 1 by 2, it is equal to 0.5907. It is greater than 0. So therefore f of 2 greater than 0. Okay, if you start with 0, if you substitute 0, f of 0 is also negative value, minus 1 by 2 will come. So therefore it is less than 0. Next number is 1. For 1 also it is less than 0. So next number 2, for 2 it is greater than 0. So therefore less than 0 greater than 0 came consequently. So therefore, so f of 1 less than 0, f of 2 greater than 0, both have opposite signs. Okay, then the roots lies in between 1 and 2. For this iteration method also, beginning of the initial approximations is same as bisection method and regular falsy method only. Okay, now we have to convert f of x is equal to 0 into x is equal to pi of x. Okay, this is the from here the process will change. Okay, up to find the a comma b values, that is the initial approximation values. Okay, so up to a comma b values, the process will resembles to the bisection method and falsy method. Now from here, the given equation whatever is there f of x, okay, equal to 0, that equation we have to convert into x is equal to pi of x. X is equal to pi of x. So now you can see the given equation x minus sin x minus 1 by 2 is equal to 0. Okay, so except x, send the remaining all terms to RHS. So x is equal to sin x plus 1 by 2. Okay, x is equal to sin x plus 1 by 2. Now it is in the format of x is equal to pi of x. Only x term represents the LHS, and rest of the terms, whatever them, yeah, trigonometric function, algebraic function, logarithm or constant, whatever it may be, exponential also. So these all terms you have to send them RHS. Only x, algebra term x only represents the LHS. So therefore x is equal to pi of x. Okay, so therefore where pi of x is equal to 1 by 2 plus sin x. So after getting that x is equal to pi of x form, now we have to do the process of conditions for convergence. Okay, conditions for convergence. In this iteration method, we have to find out one condition, that is differentiation of the phi of x. Pi dash of x is equal to, for 1 by 2 differentiation is 0, and sin x it will become cos x. Okay, pi dash of x is equal to, for 1 by 2 constant 0 plus sin x differentiation is cos x. So therefore cos x. Next to that differentiation, we have to find out the differentiation value at x is equal to 1. Okay, at x is equal to 1. So therefore phi dash of x at x is equal to 1 is equal to mod cos of 1. So therefore, if you calculate that value, okay, that value gives that 0.5403. Okay, so this 0.5403 is less than 1. Less than 1 at x is equal to 1. So therefore, pi dash of x at x is equal to 2. Therefore, mod cos 2. This value gives 0.4161. This 0.4161 is also less than 1. Okay, what here I am going to say that in the method of iteration, first of all, we have to find out the given equation has opposite signs. After that, we have to write down the values of a comma b. After that, to get the approximations, first of all, we have to convert the given equation as x is equal to pi of x. After converting that given equation x is equal to pi of x, we have to take the derivation of pi of x with respect to given variable only. So therefore, pi dash of x. After taking the derivation, now with respect to a and b values, here a and b is nothing but 1 comma 2. With respect to 1, with respect to 2, we have to find out the magnitude value of the difference. Okay, what is the magnitude value? Phi dash of x is the derivative. If you apply the mod, we have to prove that it is less than 1. Okay, phi dash of mod phi dash of x is less than 1, then we can apply the conditions for the convergence. Okay, then clearly we can say that the required root lies in between 1 comma 2 only. For at x is equal to 1, we proved that that value is less than 1. At x is equal to 2, we proved that that value is difference of phi of x at magnitude x is equal to 2 is less than 1. Next, so therefore, pi dash of x, okay, mod of pi dash of x less than 1 at small x belongs to closed interval 1 comma 2. Hence, iteration is applicable for the given function whenever this condition exists. In the general procedure only, we can say in this format only. In general procedure also, mod phi dash of x less than 1, that is in the general procedure only. So therefore, whenever it satisfies the given interval, then we can say clearly say that iteration process applicable for the given function. Now, formula for the general iteration. Okay, that formula is x suffix n plus 1 is equal to pi of n. X suffix n plus 1 is equal to pi of m. You know very well, x is equal to pi of x. Okay, for that equation only we are applying that suffixes. X suffix n plus 1 is equal to pi of xn, that is taken as equation number 1. Let the initial approximation be, okay, here initial approximation, how we can say the average value of 1 comma 2. Okay, so therefore the near value you can take. So therefore x naught is equal to 0.5. Okay, we are considering this value. It is not average value of 1 comma 2. So we are considering that initial approximation x naught is equal to 0.5. With the help of that x naught, first of all I am writing first iteration. The name of the method is iteration. So that's why we are taking that first iteration. In the previous methods we took it as first approximation. Now first iteration. For n is equal to 0 in equation number 1. Okay, then it will become x suffix 0 plus 1 is equal to pi of x suffix 0. So already we know very well x suffix 0 value. So x1, LHS x1 is equal to pi of x naught. Substitute x naught in pi of x. So therefore 1 by 2 plus sin x naught. That is 1 by 2 plus sin x naught is nothing but 0.5. So 1 by 2 in the decimal format 0.5 and sin 0.5 value is 0.47926. Okay, you have to calculate with the scientific calculator. So therefore, by clubbing them, by adding them, you will get x1 is equal to 0.9794. 0.9794. This is the first iteration. Okay, so how you get that first iteration? By assuming x naught is equal to 0.5. Okay, so that is next second iteration. For n is equal to 1 in equation number 1, we get that x1 plus 1 is equal to pi of x of 1. Okay, 1 plus 1 is nothing but x2. x2 is equal to pi of x1. So therefore x2 is equal to, substitute the phi of x function 1 by 2 plus sin x, in place of x here x1. So therefore 1 by 2 plus sin of x1. So substitute the x1 value 0.9794 and calculate that value. You will get x2 value. x2 is equal to 1.3302. Okay, 1.3302, that is the x2 value, second iteration. Okay, these all are the first iteration, second iteration are the approximation roots only. We have to continue this process until we'll get the as possible as required root. Okay, therefore third iteration, in third iteration for n is equal to 2, for n is equal to 2, in equation number 1 you will get x of x3 is equal to pi of x2. Same, 1 by 2 plus sin x2, so 1 by 2 plus sin of 1.3302, sin x2 value, if you simplify this x3 you will get 1.4712. Next, similarly fourth iteration for n is equal to 3, for n is equal to 3, in equation number 1 x of x4 is equal to pi of x3, so that if you simplify that value you will get x of x4 is equal to 1.4950, 1.4950. Next, fifth iteration, n is equal to 4, n is equal to 4 in equation number 1, so x of x5, if you simplify that, x of x5 is equal to 1.4971. Next, sixth iteration, n is equal to 5 in equation number 1, so therefore then you will get that x of x6 is equal to 1.4973, 1.4973. Next, seventh iteration for n is equal to 6 in equation number 1, so therefore you will get that seventh iteration. So therefore if you substitute and simplify those total process, you will get that x of x7 is equal to 1.4973. Okay, up to here it is okay. Now our time we have to observe the required values. If you observe x of x6 1.4973 and x of x5 1.4971, up to 3 digits same, 497 497 497. Okay, for the last two iterations 4973 4973, last 4 digits also same. Okay, from the statement of the problem what is said clearly, find the real root of the given equation exact to 4 decimal places. Okay, 4 significant figures, 4 significant figures. Significant figures we can write okay, right side part of the decimal, so therefore here 1973. Therefore from the 6th and 7th iterations clearly we can say that x is equal to 1.497, 1 2 3 4 are the 4 significant digits, so therefore is the required root of the x minus sin x is equal to 1 by 2, correct to the 4 significant digits or correct to 3 decimal places. 4 significant digits అని చెప్తాం, ఎందుకంటే వీటన్నిటిని కౌంట్ చేస్తే ఇక్కడ 1 2 3 4 ఇవి మనకి ఎన్ని ఉన్నాయి, 4 ఉన్నాయి, 4 డిజిట్స్. ఓకే, including all elements. Okay, left to and right of the decimal point. 4 significant digits కాకుండా 3 decimal points కూడా అంటాం దాన్ని. డెసిమల్ పాయింట్స్ అంటే డెసిమల్ కి రైట్ సైడ్ లో ఉండేవి ఓన్లీ 497, అవన్నీ ఉన్నాయి మనకు 3 ఉన్నాయి. ఎగ్జామ్ లో అప్ టు 3 డెసిమల్ పాయింట్స్ అంటే ఇదే, లేదంటే 4 సిగ్నిఫికెంట్ పాయింట్స్ అన్న కూడా మనకు ఇదే. ఓకే, దట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ significant digits and decimal digits. Okay, so therefore in this method iteration process will exist. By using the iteration process we can find the approximation root of any real root of any equation. Okay, so I hope you understood this problem very well. Now here you can see the table at the end of the clearly mentioned you at the end of the problem, so you have to mention the table: initial approximation, first approximation, second approximation, third, fourth, fifth, sixth, seventh. Okay, in sixth and seventh the root is same. Okay, repeated, so therefore you have to terminate the process there only. Then clearly you can say that 1.4973 is the required root up to 5 significant digits. But మనకి ప్రాబ్లం లో ఏమడిగాడు 4 అన్నాడు కాబట్టి ఆ 3 ని కట్ చేస్తాం, 497. Okay, 1.497 is the required root. So therefore based on this iteration method in 2022 June July, in 2022 June July question paper lo we have he has asked one long answer question. Okay, that is in question number 13. 13a వచ్చేసి మనకి ఏంటంటే find prove that the rate of convergence of the Newton-Raphson method is quadratic convergence. Okay, Newton-Raphson method has quadratic convergence. Quadratic convergence, this one is the first option. In 13 question only B, prove that or find the real root of um, sin x is equal to 10 of x minus 1 by using the iteration method. Okay, so therefore మీకు ఎగ్జామ్ లో ఏ మెథడ్ ని ఎక్కడ అడిగేది తెలియదు. ఓకే, సో కాబట్టి సో ఈ ఫస్ట్ క్వశ్చన్ ఏంటంటే న్యూటన్ రాప్సన్ మెథడ్ కి మనం రేట్ ఆఫ్ కన్వర్జెన్స్ 2 అని చెప్పాలి, క్వాడ్రాటిక్ కన్వర్జెన్స్ 2 అని ప్రూవ్ చేయాలి. అది కూడా మనకు నెక్స్ట్ అప్కమింగ్ థియరమే. సో ఈ ఆప్షన్ బి చూసుకుంటే మీకు ఏంటంటే sin of x is equal to 10 into x minus 1. సో ఇక్కడ మీకు ఇది ఉంది, sin of x is equal to 10x minus 10 అని మరి మీరు రాసుకుంటారు. దీన్ని మనం ఎలా ఇటరేషన్ మెథడ్ యూజ్ చేసుకుని ఎలా సింప్లిఫై చేస్తామంటే 10x ని అక్కడ పెట్టుకొని -10 ఇటువైపు పంపించుకున్నాం అనుకోండి, sin x plus 10 is equal to 10x. మనకేం కావాలి, x is equal to pi of x ఫార్ములా. సో therefore ఓన్లీ x ని అక్కడ పెట్టుకొని 10 ని డివైడ్ చేసుకుంటే sin x by 10 plus 1. So this is the required x is equal to pi of x condition. So after getting that x is equal to pi of x, you know very well, you have to take the derivation of the pi of x. After taking the derivation of the pi of x, you have to apply the magnitude. You have to find out the magnitude is less than 1 at a comma b. So therefore after that by assuming the initial approximation x naught value, okay, so you can solve the problem. So in this format we can proceed. This question has asked in the previous examination 2022. So that is question 13b. So I hope you understood this problem very well. In the next lecture we are coming with another important theorem. Okay, so prepare well, make a perfect practice. Until bye, thank you.